Hello everyone, hope you are all right. In our previous session, we learned the structure of the human eye. We have also learned power of accommodation. In this session, we will learn defects of vision and their correction. We know that sometimes the eye may gradually lose its power of accommodation. Let us recall what is power of accommodation. The ability of the eye lens to adjust its focal length is called accommodation. So, it may happen that the eye gradually lose its ability to adjust its focal length. In such conditions, the person cannot see the objects distinctly and comfortably. Distinctly means clearly. So, people cannot see the objects clearly and comfortably when there is a loss of power of accommodation. The vision becomes blurred due to the refractive defects of the eye. Because there are some defects for vision, these things arises. And what are these defects? So let us see what are they. There are mainly three common refractive defects of vision. First is myopia or nearsightedness. Second is hypermetropia or farsightedness. And third is presbyopia. And these defects can be corrected by the use of suitable spherical lenses. Now, students, we have already learned about spherical lenses in chapter number 10. Now, let us discuss each defects of vision and their correction. Let us first talk about myopia. Myopia is also known as nearsightedness. A person with myopia can see nearby objects clearly but cannot see distant object clearly. So how will you remember? You will remember that myopia is nearsightedness. And what is happening with this defect? It is a nearsightedness, which means you will remember that in nearsightedness we can see the objects which are nearer clearly, but the objects which are far that cannot be seen clearly. So you will remember nearsightedness means the nearby objects can be seen clearly. It is easy to remember, right? A person with this defect has the far point nearer than infinity. Now, in our previous session, we learned about near point and far point also. What is the meaning of far point? The point up to which the eye can see objects clearly is called the far point of the eye. The farthest point up to which a person can see. And we know for a normal eye, the far point is infinity. Okay, that we have discussed. But a person with this defect will have far point nearer than infinity. We have learned for a normal eye, it is infinity. But a person with this defect will have far point nearer than infinity. So, such person can see clearly up to distance of few meters only. Now, what is happening? We know that the image must be formed on the retina because retina acts as the screen. So the image must be formed on the retina. But the eye with this defect is called myopic eye. What will be happening with myopic eye? Let us understand. So, in a myopic eye, the image of a distant object is formed in front of the retina. In the figure, you can see the three figures are there. In that, refer to figure B, myopic eye. Here we can clearly see that the image is formed in front of the retina. Actually, where has it should be formed? On the retina. But for myopic eye, it is formed in front of the retina. Why does this effect arise? This effect may arise due to excessive curvature of the eye lens. If the eye lens has more curvature, we already learned in previous session what is curvature, right? The degree of the lens up to which it can be curved. So it may happen that the excessive curvature is there of the lens. Also, elongation of the eyeball. This defect can be corrected by using a concave lens of suitable power. So here, which lens is to be used for correction of myopia? Concave lens. Now in chapter number 10, we have learned that the concave lens is also called diverging lens. Okay, because concave lens is able to diverge the light ray after refraction. So, with the help of concave lens, we can diverge the light rays after refraction. So, here, why is the concave lens used? Because concave lens will help to diverge the lens. So, when the rays are coming parallel, what will happen? The rays will be first diverged by concave lens. As a result, the image will be formed on the retina. So, to correct myopia, we need to use a concave lens. So, here this is all about myopia. Let us once again revise it. For myopia, image is formed in front of the retina, but where actually it should be formed? On the retina. So for that we use concave lens, which is a diverging lens, and concave lens help to diverge the light rays, and then the image is formed on the retina. So this is all about myopia.